So this video is going to be on 1057 and 10-59 and 10-60. So on 10-57, what we're going to be looking at is we're going to be looking at investment A, investment B, and investment C. And we want to see what's happening with each of those. So if I am just looking at investment A and I'm trying to figure out what's happening here, every month I am increasing by 10 each month. So that's going to make this linear. So this is going to be y is equal to 1,000 plus 10x. And again, for A, we're increasing by $10 each month. On B, we're not adding the same amount each time. So I'm thinking maybe we are multiplying. So I am going to take 1,010 and divide it by 1,000. When I do, I get 1.01. And if you double check it, we are multiplying. Okay, we're multiplying by 1.01, by 1.01, and so forth. So that makes this exponential. Y is equal to 1,000 times 1.01 to the power x. And so B is increasing by 1%. Okay. And if something's increasing by 1% per month, that means in this case that my multiplier is 1.01. Then if I'm looking at C, I notice I'm increasing by 1, then by 3, then by 5, then by 7, then by 9, then by 11. And so here we're increasing each month by 1, and then 3, and then 5, and then 7, and then 9, ... Now that's actually quadratic. Now what I notice is that we have a 1, a 4, a 9, a 16, a 25, and a 36. And what I notice is I'm adding 1 for month 1, 4 for month 2, 9 for month 3. I have 16 more by month 4 and so forth. So what I'm noticing is that each time onto the 1,000, I either added 1 squared, or I added 2 squared, or I added 3 squared, and so forth. So this one's going to be y is equal to 1,000 plus x squared. And this one is quadratic. Again, the middle one was exponential. And then the first one was linear. Now they want us to calculate the average rate of change for each month. So average rate of change, not for each month, but from month 4 to 6. So basically it's slope. Now these don't all have a slope because these are all not all linear. But what they want is they want us to compare the change between month 4 and 6. So for A, when I subtract, I have a difference of 20 every 2 months, which is $10 per month. When I'm looking at B, and I am trying to do that subtraction, so Let me just get a calculator. Okay, so I'm taking 61.5 minus 1040.6. I got 20.9. I'm going to divide that by the change of X, which is 2 months, and I get 1045. Okay. So for B, I ended up with 20.9 when I did that math, divided by 2 gave me 1045 per month. And then when I'm looking at C, I'm going to be subtracting again those 2 months. 1036 and 1016 is going to give me 20 every 2 months, which is $10 per month. Now it says assume each investment continues to grow in the same way it has been growing during the first 6 months. If Marty plans to invest his money for many years, which investment is the best choice? Okay, so I'm going to pull Desmos over here. I am going to get the, whoops, not what I wanted. Get the equations in here. So y is equal to 1,000 plus 10x. Y is equal to 1,000 times 1.01 raised to the power x. And y is equal to 1,000 plus x squared. Okay, let me just get this up so we can see it. And I am going to change the scale of this. So I'm going to change my x's, let's say from year 0 to, let's say, year 40. I need to start at 1,000. And let's say I go up to 10,000. Okay. So let's kind of take a look at these. So this purple one is my linear one. Okay. This red one is my quadratic one. And this black one is my exponential. So looking at it, let me just kind of change the scale here. So let's go up to 20. And let me scale this from 0 or 1,000 to 10,000, let's say. Okay. Change the scale a little. So as I'm looking at it, it looks like the parabola is going to be the best, but it depends on how many months, because eventually the black one, which is the exponential, is going to end up meeting it. Now that's going to be in 587 months. So if I take 587 months divided by 12, that's going to be 48.9 years. So in 48.9 years, the exponential is going to be better than the quadratic. Okay, exponentials will always eventually be better if it's an increasing exponential. But in this situation, it would take 48 months. Okay, so assume each investment continues to grow in the same way. It's shown over the 6 months. If Marty plans to invest his money for how many years, which investment's the best choice? So if it's for under, so if it's over 48 years, the exponential, which is b. If it is for, let me get back to the table. If it is, so if we're looking at the table, so if it's for 48 years, okay. But if it's short of 48 years, okay, short of 48 years, I would probably say the quadratic would be the best. Okay. And on 59, we have a wire fencing sold in rolls of 100 linear feet. Okay, so that's like your perimeter, if you want to think about it that way, or circumference, depending on what shape we're doing. A farmer builds a rectangular pen. So, okay, it's a rectangular pen. And we know that the length of the pen is 2 feet less than 3 times the width. Okay, so I am going to call this width. This is width. And then the length is going to be 2 less than 3 times the width. Write 2 equations to determine the dimensions of the pen, one using area and one using perimeter. So perimeter is going to be basically 2 times W plus 2 times 3W minus 2. Okay. And that's going to end up being 2W plus 6W minus 4. So that's going to end up being 8W minus 4. That's my perimeter. Okay, area. Area is going to be length times width, so it's going to be W times 3W minus 2. So that is going to be 3W squared minus 2W. Now, we know a couple things. So we know that the perimeter is equal to 100. So I go 100 is equal to 8W minus 4. So I get 104 is equal to 8W. And when I divide 104 by 8, I end up getting 13 for my width, which means that 3 times 13 minus 2, so 39 minus 2, my length is going to be 37. Now, if I'm dealing with area, the area is 481. So I'm going to go 481 is equal to 3W squared minus 2W. So 0 is equal to 3W squared minus 2W minus 481. Now, we could try to factor this and see if it is factorable, but I'm just going to jump to quadratic formula. So I'm going to go W is equal to 2, because that's negative B, plus or minus the square root of B squared. So that's negative 2 squared, which is 4, minus 4 times my A, which is 3, and my C, which is a negative 481, all over 2 times my A, which is 3. So this is going to be 2 plus or minus the square root. And if I do the math, I'm going to have 4 minus 4 times 3 times a negative 481. I end up getting 5,776. And when I take the square root of that, so 5,776, the square root of that is 76. So I get 2 plus or minus 76 over 6. So when I go to plus, I get 78 over 6. And 78 divided by 6 is, so 78 divided by 6 is 13. Now, if I do the minus, I get a negative 74 divided by 6, and that doesn't make sense. Doesn't make sense to have a negative side. So my width is going to be 13. And again, if my width is 13, which I had up there, my length is going to be 3 times 13 minus 2. So that is going to be 39 minus 2, 37. Just move this. On 60, we have to do they want us to do a proof, okay, a flowchart proof. We know M is the midpoint of K to Q. And we also know that measure of angle P and L are the same. And we want to prove that KL is congruent to KP. Okay, so I know that angle L is congruent to angle P given. So that is, this angle here is the same as this angle here. I also know that this angle here is the same as this angle here because of vertical angles. So that is going to be angle KML is congruent to angle QMP. And the reason, sorry, angle QMP, and the reason is given. Oh, no, sorry, they didn't give us that. Vertical angles. Now, we also know that KM is congruent to MQ. That is by definition of midpoint. So at this point, I know that these two triangles, triangle KML is congruent to triangle QMP. The reason is angle, side. Now we want to prove that this side here is congruent to this side here. Now, since they're in the same spot, KL and QP are going to be congruent to each other. So we're going to say that this leads to, the fact that these triangles are congruent leads to line segment KL being congruent to line segment QP. And the reason is congruent triangles lead to congruent parts. And that's the end of this video.